All right, for 4.1, we're going to talk about properties of radicals. So first we're going to talk about simplifying. And we're going to use the product property to do this. So the product property of radicals, we have the square root of a times b. That's going to be equal to root a times root b, where a and b are greater than or equal to 0, right? Because we can't take the square roots of negative numbers. Now, let's look at an example of how to simplify a radical. So for number 1, we have the square root of 48. So we're actually going to make a factor tree and break this down. So what two things multiply to 48? Well, we could do 6 times 8. And then if we're looking at 6, what would break down to 6? Well, we could do 2 times 3. Now we want to can we break down 2 or 3 anymore? Not really, right? Besides 1 times 2 and 1 times 3, but that won't really help us to keep going down that path. So we're going to come over to the 8. For 8, we could do 2 times 4. And 2 is done, but for 4, we have 2 times 2. Okay, now just for some clarity, every time I break down a number, I'm going to cross it off just so that we can see we're left with 2 times 2 times 2 times 2 times 3, right? If we multiply all those together, we will get our 48. And now if we think about this, 2 times 2 is really 2 squared, right? Those 2's together. And again, with these 2's, that's also 2 squared. And if we use our product property, we know that multiplying under a radical is the same as if we have them all under their separate radicals. And really, the square root of 2 squared, well, that's just going to be 2, right? The squared and square root are going to cancel. And again here, so we have 2 times 2 times root 3 equals 2 times 2 is 4 times root 3. And that would be our simplified version of root 48. Now we can actually do this without writing out all these radicals over here. If we look in at our factor tree, you see how we have a group of 2's here, and we have a group of 2's here, and then we have 1, 3 by itself. Well, since we're breaking down a square root, that means we're looking for groups of 2, because the square root will cancel out with our things that are squared. So any groups of 2 we can pull out. So we can pull out 1, 2 from that square, and 1 from that. And then our root 3 that we have left stays under the root. Okay, so let's do another example to show this. So number 2, we have the square root of 108 x to the 5th. Now we're going to do 108 and x to the 5th separately. First, if we look at 108, what multiplies to 108? Well, we could say 12 times 9. And again, I'm just going to cross off once I've broken something down. So 12, we could break down to 4 times 3. 3 we're done, but 4, 2 times 2. And then 9, we can do 3 times 3. So now if we look, we're doing a square root again, right? If there's no number right here, that means we're doing a square root. So that means we're looking for groups of 2. Well, we have 2 2's and 2 3's and 1 3 left over. So that means we're going to have 1 2 and 1 3 outside. So 2 times 3. Then that 3 that's left over is going to stay under our square root. Now let's look at the x to the 5th real quick. Well, x to the 5th is just x times x times x times x times x, right? 5 x's multiplying together. So again, if we look for groups of 2, we have 1, 2. So that means we can pull out 2 x's and from under our square root, and then this x that's left is going to stay under the root. So now our final answer, we have 2 times 3, which is 6. X times x is x squared. And under our root, we have 3x. And that would be our simplified version of 108 x to the 5th. Okay, let's do another example. So first one, we have the square root of 52 times x cubed, y to the 4th, z to the 8th. So again, we'll just think of each of them separately. So if we do 52 first, what multiplies to 52? Well, we could do 26 times 2. After we break that down 2, we're done. What about 26? Well, that's 13 times 2. Will 13 break down anymore? No. So we're actually done there. So let's look. We have a group of 2 2s, and our 13 is by itself. So we're going to pull a 2 out, and then 13 is going to stay under the radical. Now let's talk about x cubed. Well, that's going to be x times x times x. So if we think about that, we have one group of 2 x's and 1 x left. So we're going to pull out 1 x, and our other x is going to stay under the radical. Now we've got y to the 4th. That's going to be y times y times y times y. So if we look for groups of 2 here, we have 2 groups of 2. So that means we're going to pull out 2 y's, one for each group. And lastly, we have z to the 8th. Well, that's going to be 8 z's, right? 1, 2, 3, 4, 5, 6, 7, 8. And how many groups of 2 do we have here? We have 1, 2, 3, 4. 4 groups of 2. So that means we're going to pull out 4 z's. 3, 4. So our final answer, we have 2 times x, and then y times y is y squared. Z times itself 4 times is z to the 4th, the square root of 13x. All right, let's look at our example number 4. So the first thing we should notice about this one is we have a cubed root. So what would be different about a cubed root? Well, that would mean we're looking for groups of 3 now, because if we had something cubed under a cubed root, that's what's going to cancel out. So now we're looking for groups of 3 instead of groups of 2. So let's do this. So we have negative 108. Now the difference with odd radicals, if you remember, we can have negatives, because if we do a negative times a negative times a negative, that's going to be negative. So since it's an odd number of multiplications, we can find the cubed root of a negative number. So let's say we have 9 and negative 12. Well, if we look at negative 12, we could say negative 3 times 4, and then 4, 2 times 2. And then what about 9? Well, we have this negative 3, and we need to pull out 3 things in a group, right? So we could actually do negative 3 times negative 3. And then we would have a group of 3 negative 3's. So we would have one negative 3 pulled out. And then now we have 2 2's, but since there's only 2 of them, they're going to stay under a root. So we're going to have 2 times 2 under the root still. Okay, now let's look at y cubed. Well, we know that the cubed root of y cubed, that's going to cancel out, right? If we have 3 y's, that's one group of 3, so we can pull the y out front. Okay, so we have negative 3 times y, and then we have z to the 4th. Z to the 4th is z times z times z times z. So how many groups of 3 do we have? 1, with one guy left under the root. So we'll have 1 under the root, and then 1 z gets pulled out front. So our final answer here, we'll have negative 3 z times y times the square root of 4z. So with whatever number you have here, whatever root it is, that's how many you're looking for in a group. So now let's look at number 5. We have the fourth root of 80. So it's the fourth root. So that means we're looking for groups of 4, right? If we have 4 of something, then our fourth root will cancel out and leave us with just that something. So how can we break down 80? Well, we could do 8 times 10. 8 is 4 times 2. 4 is 2 times 2. And 10 is 2 times 5. Now 5 won't break down anymore, but we do have a group of 4 2's. So that means we can pull 1 2 out, and then our 5 is going to stay under the fourth root. Oh, and on number 4, that should be a cubed root. So whatever root it is, it needs to stay the same. So for 5, we'll get 2 times the fourth root of 5.